Hello friends, this video on electrochemistry part 11 is brought to you by examfear.com. No more fear from exam. Let's understand Nernst equation. See, till now we have assumed that all the species involved in this reaction, all the electrolytes were 1 molar. Right? That's what we have assumed till now. But in real life, that is not true. We may take 2 molar, we may take 3 molar, we may take n molars. That may not be true, right? For example, let's consider a half reaction, reduction half reaction. Actually, for example, this guy here, the reaction will be some m with n plus ions. N electrons are transferred, it becomes m, and it becomes solid. It was aqueous here. Let's take this reaction, and it was not 1 molar. It has some concentration, and this be a reaction of this side. Correct. So the electrode potential at any concentration measured with respect to standard hydrogen electrode can be, what I'm saying is, for this concentration, the electrode potential for this half cell for E of Mn plus 2 M, this will be nothing but E naught. E naught means standard of Mn plus 2M minus RT by NF ln K for this reaction, and K is nothing but, or I'll just put K here, ln K. K is something we know, is nothing but concentration of M, which is solid, by concentration of Mn plus ions, right? That is something we know, equilibrium constant. This is the equation which was derived experimentally by this guy, and it's a very, very critical equation. So this says that electrode potential at any concentration, that is, I can say at any concentration, and this is standard electrode potential, which we generally measure using SHE, standard hydrogen electrode, right? So till now what we have done is we have used SHE, which we assume that potential to be 0. Actually it is not, and then we have found the standard electrode potential of copper, and then we have found the standard electrode potential of zinc also, assuming that everything is 1 molar. But now in real life it can be any concentration. So this equation holds true, right? Where we say that the electrode potential at any concentration is nothing but electrode potential standard minus RT by NF ln K, right? Where R is a gas constant, R is my gas constant, 8.314 joule per Kelvin per mole. F is what? My Faraday constant. I'll explain you how it came. Faraday constant. That is nothing but 96487 coulomb per mole. Sorry, per mole. And then my T is what? T is my temperature in Kelvin. In Kelvin. And what all? And this is my concentration, right? K is my equilibrium constant, and N is my number of electrons which is getting exchanged. N is number of electrons. So first let's apply this equation for Daniell cell, and then we'll try to derive this. So let's apply this for Daniell cell now. So for Daniell cell we have anode here, AC, this is cathode here. By representation, this is my zinc, this is my copper, and this is my Zn2 plus, and this is my Cu2 plus, right? Top of solution. So we'll talk about at cathode first. At cathode. So cathode, I have reduction potential from Cu2 plus to copper. So reduction potential of Cu2 plus to copper at any concentration is nothing but E naught cathode. This is my equation. E naught that we have till now we have found 0.34 volt, I think. Yeah. Minus RT by N. How many electrons are getting transferred here? 2, right? You see, 2 electrons. 2F by ln K. What is the value of K? So let's see this reaction. Here we have Cu2 plus becoming Cu solid plus 2, right? Then concentration of copper solid, and that is always 1 by concentration of Cu2 plus, that is this guy. That is my cathode. You'll find an anode. At anode, what is the reaction? This reaction I have for anode, that is nothing but my zinc is taking 2 electrons becoming Zn2 plus. Correct? Correct? But if you want to write the reduction reaction, it is nothing but flip side. The flip side is nothing but the reduction reaction will be nothing but, please note, I have to write the reduction reaction for this. Reduction reaction is Zn2 plus will take 2 electrons to become Zn. So both case I am writing reduction reaction. For finding the value of K, right, I am finding reduction reaction. That is something to note. So here I have Zn2 plus to Zn. My reduction potential is nothing but E naught Zn2 plus to Zn. That is something we know. Minus RT by N is 2 here. F ln of concentration of zinc solid, that is 1 by concentration of zinc ions. Right? Please note, it is a reduction reaction. If we had written oxidation reaction, then you would have written ln of Zn2 plus by ln of Zn solid. Right? This is Zn solid. Solid concentration 1. But we are writing reduction reaction in both cases. So we have got cathode and anode, both the value of E. So cell potential, if you want to find the E cell, is nothing but E cathode minus E anode. Let's subtract these values. E cathode is nothing but this guy, E of Cu2 plus 2 Cu minus E of Zn plus 2 Zn. Correct? What is the value of this? E of Cu2 plus 2 Cu is this guy, E naught Cu2 plus 2 Cu minus RT by 2F ln 1 by Cu2 plus, minus this value E of Zn2 plus to Zn. This is equation 1, this is equation 2. So from equation 2 I can put the value E of Zn2 plus to Zn is nothing but E naught of Zn2 plus to Zn minus same value RT by 2F ln of 1 by Zn2 plus. So you solve this, you get nothing but, this is nothing but E of Cu2 plus by 2 Cu minus, or E naught minus E naught of Zn2 plus by Zn, which we already know, the minus RT by 2F ln, this is minus, right? This whole thing is a minus actually. So minus becomes plus, it comes up. So this becomes Zn2 plus by Cu2 plus. And this is nothing but, if you see, this whole thing is nothing but standard E cell, E naught cell. Correct? So this becomes E cell becomes E naught cell minus RT by 2F ln of Zn2 plus by Cu2 plus. This is only for Daniell cell, right? So let me write this. So the final equation we got here is E of cell is nothing but E naught cell, because this is E naught cell, minus RT by 2F ln of Zn2 plus by Cu2. So that is my Nernst equation, and it gives a very good picture. It says that electrode potential or EMF of a cell at any concentration is nothing but EMF of a cell at silent potential minus RT by ln zinc concentration and copper concentration. That means the electrode or EMF of a cell at any concentration, or E cell, electrode potential of a cell at any concentration, will depend on the zinc and copper concentration. If that is 1, 1, both are 1, then ln 1 becomes 0. This is not there, right? That means the E cell at that point becomes the standard electrode potential of the cell. But if the value is different, right, if you increase the concentration of zinc, the E cell will decrease. Why? Because if you increase the concentration of zinc, the whole value will increase, and there is a negative sign here. If you increase the concentration of copper, this whole value will decrease, and there is a negative sign, negative, negative, positive. That means E cell will increase. Correct? So that is my Nernst equation for Daniell cell. It's a very, very important equation because it helps you determine the electrode potential of a cell at any concentration. I'm talking about any concentration. This is constant, this we know experimentally. At 298 Kelvin using XII you can find this, but this E cell will vary based on the concentration of electrolytes. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.